Hello everyone. Today we'll be solving a related rates problem, and our objectives will be to number one, look at a basic problem solving strategy, and number two, look at a related rates example we can use to implement that strategy. So our basic problem solving strategy will be one that was adopted from George Polya, and it's the four-step problem solving method. So step one, understand the problem. What are the known fixed quantities and what quantities are varying with time? And we will assign variables to all quantities that vary with time. The time varying is important because we will be coming through and differentiating with respect to time, and so knowing which rates we're trying to relate is part of the problem. Number two, we will devise a plan. We'll write an equation that relates the quantities identified in step one. In particular, the quantities that are varying we'll try and relate. Step three, we'll carry out our plan. Let's differentiate both sides of the equation that you developed in step number two, and we'll solve for all the appropriate unknown rates. All these rates that we'll be solving for will be in terms of time, and most of them we'll know, and usually there's only one that we don't. In step number four, we look back. As always, make sure you interpret the solution in terms of the original problem. Does it make sense? Does it seem reasonable? These are all things that you can't take for granted. So let's look at a basic related rates example. There's a 13-foot ladder which is leaning against a wall. If the top of the ladder slips down the wall at a rate of 2 feet per second, how fast will the foot of the ladder be moving away from the wall when the top is 5 feet above the ground? So the first thing to do is we need to understand the problem. So we'll draw the basic picture, which turns out to be a right triangle. There's the ladder, which is at 13 feet. Here is the ground length, which we'll call x, and then the height of the ladder up the wall, which we'll call y. We know that y is going down and decreasing, and therefore the ladder should slide that way. So the two quantities that we don't know are x and y for the quantities that are varying, and therefore they have rates. So for example, if the top of the ladder slips down the wall at a rate of 2 feet per second, so that's dy dt, and dy dt is negative 2 feet per second. And it's negative, you might want to think about y, and that's because y is decreasing in size. And then how fast will the foot of the ladder be moving away? So that's dx dt, that's the quantity we're looking for, when the top is 5 feet above the ground. So that means that y is 5, and if you look, this is a pretty well-known Pythagorean triplet of 5, 12, 13 triangle. And of course, the relationship that relates all three of these sides is Pythagorean theorem, and it says that x squared plus y squared is equal to 13 squared. So now let's differentiate with respect to time. So if we begin with our equation x squared plus y squared equals 13 squared, and we come through and implicitly differentiate with respect to time, you get 2x dx dt plus 2y dy dt is equal to 0, since the derivative of a constant is 0. So replacing all the values, and actually first notice that the 2's could cancel there because it's set equal to 0 on the other side. And if we substitute all the known values, so x was 12, dx dt is what we're looking for, y we found to be 5, or were given to be 5, and dy dt was negative 2. There's no need to worry about the units. As long as the units worked out in the original problem, so the original problem was everyone was in feet, when you come through and differentiate with respect to time, everyone should be in feet per second. So all the units should work out. If you now solve for dx dt, we should get that dx dt is equal to 10 over 12, which is 5, 6. And so to answer the question, how fast will the foot of the ladder be moving away? It will be moving away at a rate of 5, 6 feet per second, which, if you use your calculator, is about 0.83 feet per second. And that's your basic related rates problem. So to recap, in solving our related rates problem, we had our basic problem solving strategy. Number 1, understand the problem. Number 2, devise a plan. Number 3, implement our plan. And number 4, look back. And then we looked at a ladder sliding down the wall as a basic example. All right, thank you. Bye.